Good morning, students. Now we discuss about the 7.7 application of second derivatives. Under this topic, now we will discuss. You see, exercise 7.6. Now we discuss about the exercise 7.6. The first question: find the Find intervals of concavity and the points of inflection for the following functions. Subdivision 1, f of x equal to x into x minus 4 whole cube. So you see, now we discuss about the exercise 7.7. So this is the first question. So subdivision 1, f of x equal to x into x minus 4 whole cube. You see the question: find intervals of concavity and the points of inflection for the following functions. So now they ask about the intervals of concavity. So first write the given functions. The given function is f of x equal to x into x minus 4 whole cube. The next step I write it. That means what I write it means just the next step I take the differentiations. That means f dash of x. You see there is here two functions, x and x minus 4 whole cube. There is a two factor in terms of x. So I differentiate with respect to, that means with respect to x and d of uv formulas, uv into dv plus v into du. So this is the formula. So first I differentiate the x. That means x I kept it. That means I write it. So first I write it, that means I differentiate the x minus 4 whole cube I kept as it is, and next one. So next step I differentiate the x. So next term I write it the x and differentiate the x minus 4 whole cube. So the differentiation of x minus 4 whole cube equal to 3 into x minus 4 whole square. So after that this is the before the step I tell about, not this step, before the step I tell. That means before the step x minus 4 whole square common in the two terms. So I take from the x minus 4 whole square. So from this remaining terms I write it 3x plus x minus 4. So equal to next step I write it x minus 4 whole square and add the terms 3x plus x equal to 4x minus 4. So the next step what I write it means x minus 4 whole square into, there is a 4 common, so I take from this. So here 4 will come, 4 into x minus 1. So therefore f dash of x, equal to 4 into x minus 4 whole square into x minus 1. This is the first derivative. Okay, so from this and the first step, before this step there is here two steps. First we apply the differentiation of uv. From this we get this steps. Okay, so the last step is f dash of final answer is f dash of x equal to 4 into x minus 4 whole square into x minus 1. This is the answer for f dash of x. Therefore the f dash of x answer is 4 into x minus 4 whole square x minus 1. You see some steps only given here, most of the steps skip. So you just first that means you write the given function. After that there is a two factor, x factor. So you take the uv method, that means differentiation of uv. So uv into dv plus v into du. So that method I applied here. Okay, so first term I keep x and differentiate the x minus 4 whole cube. So 3 into the differentiation of x minus 4 whole cube is 3 into x minus 4 whole square. Next term, the second term plus I write it the x minus 4 whole cube and differentiate the x. So from this I take the, so my term I get the terms x minus 4 whole cube plus, that means the first term is x into 3 into x minus 4 whole square plus the second term is x minus 4 whole cube. So from this I take the common factor. The common factor is x minus 4 whole square. So I take the common factor from this. So before step I tell. Okay, so after this this is third step. So before the second, and the second step is 3 into x minus 4 whole square plus x into x minus 4 whole cube. This is the second step. This is the third step. So from the second step I take the common factor x minus 4 whole square. So from this I write it remaining factor. So remaining factor is, that means 3x plus x minus 4. So in the next step I write it, I add the factor. So that means x minus 4 whole square, 3x plus x is 4x minus 4. In the next step x minus 4 whole square into 4 is the common, so 4 into x minus 1. So f dash of x equal to 4 into x minus 4 whole square x minus 1. This is the f dash of x. Next f double dash of x. F double dash of x equal to, so in the next step again I differentiate the first derivative. So I differentiate the first derivative means I get the second derivative. So f double dash of second time I differentiate the first derivative, so I get f double dash of x. So f double dash of x equal to, again you see there is a 4 is a constant, so I write it, and you see there is a 2 factor x minus 4 whole square x minus 1. So 2 factor in terms of x. So you apply the UV method, differentiation of UV, u into dv plus v into du. So you write 4, I write it. Now I write the first term x minus 4 whole square, the second factor now I differentiate. So differentiation of x minus 1 is 1, differentiate the x is 1 and the constant term is 0. So the differentiation of x minus 1 is 1 plus next I write the second factor x minus 1. Differentiation of x minus 4 whole square is, that means I differentiate the first factor now. So the power is x minus 4 whole square means 2 into x minus 4. So in the next step, now here you see there is a common factor. So the common factor is x minus 4. Both the term x minus 4 is a common factor. So I take from this bracket. So therefore I take the x minus 4 common factor from this bracket. So 4 into x minus 4 into, I take the x minus 4. So remaining factor x minus 4 plus 2 into x minus 1. The next step I write it 4 into x minus 4. So x minus 4 I multiply the 2 in the factor, 2x minus 2. So in the next step I write it 4 into x minus 4. So I add the x terms, 3x minus 4 minus 2 minus 6. So 4 into x minus 4. Here you see the second factor 3 is a common. So I take the 3 from this bracket, from the second factor. So I take the 3 from this, so 3 into x only remaining factor, so x minus remaining term minus 6 is I take the 3 from the 6, so minus 2. Therefore f double dash of x equal to, now I multiply the numbers, 4 3s are 12 into x minus 4 x minus 2. This is the f double dash of x answer. Because you see, find the intervals of concavity means concavity, that means it needed the f double dash. So f double dash greater than 0 means it is a minimum, so f double dash less than 0 means it is a maximum. So we must need the f double dash. So for that reasons we find out the f double dash. So we need the f double dash means first we find out the f dash. So here in this problem we find out the f dash, after now we find out the f double dash. The f double dash, now I take f double dash equal to 0. So f double dash of x equal to 0. So now I write the f double dash answer, 12 into x minus 4 into x minus 2 equal to 0. This is the f double dash answer. There is a 2 factor. The first factor is 12 into x minus 4, second factor is x minus 2. So this is equal, both the factor equal to 0. Now I equate the 0 to each factor. So I write it 12 into x minus 4 equal to 0, x minus 2 equal to 0. So 12 is any numbers not equal to 0, so we omit that. Only terms only, the x variables and its factor only 0 equal to 0 we consider. So I write it x minus 4 equal to 0. So x minus 4 equal to 0 means that this minus 4 I write in the RHS. So minus it converted into plus in the RHS, sign changes. So x equal to 4. The next step, in the second factor again I equate to x minus 2 equal to 0 means this minus 2 I write in the RHS. So minus it comes to the plus in the RHS. So x equal to 2. Therefore we having x values 4 and 2. Now I mark it this x and x values in the number line. So I take the number line minus infinity to plus infinity and mark the line, mark the number 2 and 4 in the number line. That means minus infinity. First we mark it the small numbers, after we mark it the big number. So we know that number line started from small to big. So 2 4. So this is the number line. Now I make it the intervals. The intervals are, so here I consider, you see there is a minus infinity to 2 one interval, 2 to 4 one interval, 4 to infinity third. Here you see this is a 4, not 14, 4. 4 comma infinity. This is the third interval. So our question is find the intervals of concavity. They ask about the intervals of concavity. So now we make it the intervals. Now we check it the concavity. You see, now sign of f double dash. Here I take not f dash, I take the f double dash. Okay, so f double dash, so f double dash of x. Now we check it the intervals and we find out the concavity of the intervals. So here I make it the table. First column is interval, second column is sign of f double dash. Here f double dash will come, f double dash of x. Next monotonicity. Now so we know the monotonicity in the definition. Monotonicity means it represent the, that means increasing and decreasing functions. Now you see, so interval, now already in the previous step we find out the 3 intervals, so I write it minus infinity comma 2, 2 comma 4, infinity comma 4, and the next sign of f double dash. Here f double dash will come. So now I substitute any number, that means minus infinity comma 2. I substitute any number from this interval. Before the 2 I take x equal to 1. So I take x equal to 1 and substitute in the f double dash of x. So substitute in the f double dash of x, it comes to the plus answer, plus symbol in the answer. So plus symbol means I take that is a concave upward. Next again in the second interval, again 2 to 4 I take a 2 to 4 means 2, 3, 4. So between the you take any whole numbers, lot of numbers in the between this 2 and 4. So I take the number, that means one number x equal to 3 and I substitute in the f double dash of x. I got the negative symbol in the minus sign in the answer. So I only represent the minus, plus sign only I represented here. So before this interval represented the plus answer, so plus, here minus answer. So minus means we represented the concave downward. So plus means we tell about concave upward, minus means we represent concave downward. So the third interval infinity comma 4. Infinity comma 4 means, you see the interval, we know that infinity comma 4 means in the before the number 4, that means this is a 4 comma infinity, not infinity comma 4. First minus infinity comma 2, 2 comma 4. Here the interval is 4 comma infinity. 4 comma infinity means that means the interval started from after the 4, that means 4.1, 4.2. So now we consider 3, that means 5. After the 4 we consider the whole numbers 5, 6, 7, 8. It goes on. Okay, no limit for the numbers because it comes to infinity. This interval is 4 comma infinity. So 4 comma infinity means I substitute any number. Suppose after the 4 the number is 5, so x equal to 5 I take and substitute in the f double dash of x. So I substitute x equal to 5 in the f double dash of x. I got the answer, that means the plus in the answer. Okay, I got the symbol plus in the answer. Therefore there is a plus sign, so I tell it is a concave upward. So from this table I conclude that that means the curve is concave upward on minus infinity comma 2 and 4 comma infinity. The curve is concave downward on 2 comma 4. So f double dash of x changes its sign when it passes through x equal to 2. Now you see the table, there is a sign changes, first plus, next minus, plus. So 2 times sign changes. So first I consider the plus, that means plus and minus. So at the point here x equal to 2, so I write it f double dash of x changes its sign when it passes through x equal to 2, and again and next x equal to, here you see this is a 4 comma infinity, minus 2 plus, so at x equal to 4. So next when x equal to 2, now I substitute x values, x equal to 2. What about the function? So in the function we know the given function, so in that function I substitute x equal to 2. So f of 2 equal to 2 into 2 minus 4 whole cube. 2 into 2 minus 4 whole cube means minus 2 whole cube, minus 2 whole cube means minus 8. 2 into minus 8 minus 16. Next, when x equal to 4, x equal to 4 means here I substitute 4, f of 4. F of 4 means 4 into 4 minus 4 whole cube. The 4 cancelled, so our answer is here f of 4 will come. F of 4 equal to 0. This is our answer. So therefore the point of inflection are, so we find out the 2 point. First point is I substitute x equal to 2, I got the answer minus 16. So the first point 2 comma f of 2, I take the y. So because y equal to f of x, so y equal to minus 16 means 2 comma minus 16. Next, x equal to 4, write it under the f of 2 values. This is the y equal to 0. So the point is 4 comma 0. So point of inflection are, that means minus 2 comma that means not minus 2 comma minus 16 and 4 comma 0. These 2 points are we call point of inflection. You see, this is second subdivision. Find the intervals of concavity and the points of inflection of the following. So now again this is second subdivision. Our question is find the concavity. Concavity means it is upward and downward. So f double dash sign, that means we find out the interval. After that we substitute any value from that interval in the f double dash. We get the minus sign, is it is a concave downward, plus answer means we represent the concave upward. So you see, first the question is find concavity. Concavity means it is upward and downward, concavity upward, convex downward. So next they ask about the point of inflection. So first I write the given function f of x equal to sin x plus cos x, 0 less than x less than 2 pi. Next f dash of x equal to, I differentiate the sin x. Differentiation of sin x is cos x, and differentiation of cos x is minus sin x. Next again f double dash. Next I find out the second derivative. F double dash of x equal to, I differentiate the cos x. Differentiation of cos x is minus sin x, minus differentiation of sin x is cos x. So this is the f double dash. Now we find out the interval. So find out the interval means we take f double dash of x equal to 0. From this we will find out the interval. So here I consider f double dash of equal to 0 because we find out the intervals. For that reasons I take f double dash of x equal to 0. So concavity means it is check from the f double dash of x. So minus sin x minus cos x equal to 0. The next step I write it, that means here, that means I write it minus cos x in the RHS means sin x equal to cos x. Next I change sin x equal to, otherwise this minus sin x you write in the RHS. So minus cos x equal to sin x. In the next step you reverse the equation. So sin x equal to minus cos x. So next step I just again, that means this minus and this cos x, I consider only cos x. Cos x I write in the denominator. So sin x by cos x equal to minus 1. So sin x by cos x is that means equal to minus 1. So sin by cos is a tan x. Tan x equal to minus 1. So tan x equal to minus 1 means so tan n pi, we know the, so tan x equal to minus 1 means the x value is 3 pi by 4, 7 pi by 4. So because they gave the limit 0 comma 2 pi, so I write it at 0 comma 2 pi. Therefore I put the here 0 plus 0 not minus. So 0 and 2 pi I mark it under this intervals I take, that means 3 pi by this angles I take 3 pi by 4, 7 pi by 4. So now I take the, I make the interval 0 comma 3 pi by 4, 3 pi by 4 comma 7 pi by 4, 7 pi by 4 comma 2 pi. So now we found the intervals. So from this we tell about a concavity. You see, interval sin of f double dash here. Concavity means we take the f double dash sin of f double dash of x monotonicity. Now I consider the interval. First column is interval, second column sin of f double dash, third column monotonicity. So first I write the intervals 0 comma 3 pi by 4, 3 pi by 4 comma 7 pi by 4, 7 pi by 4 comma 2 pi. Now so sin of f double dash. So sin of f double dash means, you see, now I take the any angles, that means between the angle angle from this interval, and I substitute in the f double dash. So for example, x equal to 30 degree in the f double dash of x, I got the answer minus symbol in the, that means I got the symbol minus sign in the answer, so I represented minus. Okay, so any degree you substitute in the f double dash between this 0 and 3 pi by 4, between the angle you substitute, so we got the answer minus, got the symbol minus in the answer. So minus means we represented concave downward. So next 3 pi by 4 comma 7 pi by 4. Second interval, you see the second interval 3 pi by 4 comma 7 pi by 4. 3 pi by 4 comma 7 pi, we take the degree, that means 3 pi by 4 means we just substitute the pi is 180. So 180 by 4 divided the 180 means we got, that means 45. So 45 into 3 is 135. So 135 degree comma, next 7 pi by 4 is 350. So 135 degree to 315 degree. So in between any degree you take any degree from this interval, so and substitute in the f double dash of x, you got the symbol plus in the answer. So suppose you substitute that means you substitute 180, so that means it started the interval started from 135 degree to 350. So you take a substitute x equal to 180, and that x equal to 180 you substitute in the f double dash of x, you got the symbol plus in the answer. So here plus symbols, so I tell it is a concave upward. So next 7 pi by 4 means 315 comma 2 pi means 360. So 315 comma 360, you see again, that means 315 means you take the 315 and the limit started from, and I tell in the degree 315 comma 360. So from this you choose any degree and substitute in your f double dash of x. Your answer is, your symbol, you get the symbol is minus in the answer, so I represented minus. This is the minus means you tell concave downward, plus means you represent concave upward, minus means you write concave downward. So you choose any angle in this interval and substitute in the f double dash of x. So you got the symbol, which symbol you got, you write it here. From this interval I got the sign minus and plus and minus. So now I write the concave downward, concave upward, concave downward. From this table I conclude that the curve is concave upward on, now it is a concave upward on 3 pi by 4 comma 7 pi by 4. Next the curve is concave downward on 0 comma 3 pi by 4 and 7 pi by 4 comma 2 pi. So this is the curve is concave downward on 0 comma 3 pi by 4 and 7 pi by 4 comma 2 pi. This is the, I mentioned the concave upward and concave downward from the above table. So next f double dash of x changes its sign when it passes through x equal to 3 pi by 4 and x equal to 7 pi by 4. So you see the table, the sign changes, minus plus plus minus, so sign changes. So I write it, it is here you see the table, here minus plus plus minus, sign changes. So sign changes from at the point 3 pi by 4, x equal to 3 pi by 4. Next plus minus, sign changes from 7 pi by 4. So at the 2 point the sign changes. So I represented the next step. You see, listen, f double dash of x changes its sign when it passes through x equal to 3 pi by 4 and x equal to 7 pi by 4. Now I substitute x equal to, because the sign changes at this point, so I take x equal to 3 pi by 4 and substitute in the given function. So our given function is f of x equal to sin x plus cos x. So I substitute x equal to 3 pi by 4. So sin 3 pi by 4 plus cos 3 pi by 4. Therefore I write it, the 3 pi by 4 is pi minus pi by 4, because it just cross multiply. 4 into pi, 4 pi. 4 pi minus pi is 3 pi by 4. Plus next cos into, again I write it the 3 pi by 4, I write it pi minus pi by 4. In the next step I write, that means I write pi minus pi by 4. So pi minus pi by 4 means, you see the quadrant 180 degree, in the middle is minus sign. So 180 degree means we know the quadrant first, second, third, fourth. So in the middle is minus sign means we rotate downward. So downward means first 360, after that 180. So it come to the third column. So it is a, that means it come to the third column means we write it, that means the pi minus. So here that means not third column, it is a first is 0, 90, 180. Okay, 180, 270, 360. So we here you see the minus sign. So minus sign means we rotate from the downward. So I rotate, the fourth quadrant will come, it is a 360. After that I come to the third quadrant, it is a 270. After that I come to the second quadrant, 180. So in the second quadrant only 180. So 180 degree I stay, that means I put. After that I come to that quadrant, second quadrant. This pi minus pi by 4 represent the second quadrant. So I come to second quadrant. You see in second quadrant, sine and cosine only positive. So sine and cosine only positive means I take sine of, so sine of pi by 4 I write it. Next in the second quadrant, cos is a negative. So cos of pi minus pi by 4 is, I write it minus cos pi by 4. Okay, because pi minus pi by 4 represent the second quadrant. In the second quadrant, sine angle is, that means sine of pi minus theta equal to sine theta, cos of pi minus theta equal to minus cos theta in the second quadrant. Because the second quadrant sine and cosine only positive, remaining functions are negative. So I write it minus cos pi by 4. So in the next step, pi by 4 means it is the 45 degree. Sine 45 degree is 1 by root 2 minus cos 45 degree is 1 by root 2 equal to 0. So next step, so f of, that means 1 by 2 cancelled, so our answer is 0. So f of 3 pi by 4 equal to 0. This f of x equal to, usually f of x equal to y, so y equal to 0. Y equal to 0 means we know the x point 3 pi by 4, y answer is 0. So point is 3 pi by 4 comma 0. This is the first point, inflection point. Next inflection point, next second, I substitute the second point, x equal to 7 pi by 4. So when x equal to 7 pi by 4, f of 7 pi by 4 equal to sine 7 pi by 4 plus cos 7 pi by 4. And again I write it, 7 pi by 4 means I write it 2 pi minus pi by 4. So I just cross multiply, 2 pi into 4 is 8 pi, 8 pi minus pi is 7 pi by 4, plus cos into 2 pi minus pi by 4 is again cos 7 pi by 4. So I write it 2 pi minus pi by 4. So in the next step, now again you see the quadrant, this angle lie in which angle. So now we find out the quadrant for this angle, 2 pi minus pi by 4. You see there is a minus sign in the middle. Minus sign in the middle means we rotate downward. From the downward we rotate. Plus sign in the middle means we rotate upward. From the upward we rotate. Okay, so we know the angle of the quadrant. The first quadrant is represented 0, second, suppose I tell it is a 4 lines, 0, 90, 180, 270, 360. Okay, so there is a minus sign, rotate from minus, that means downward. So downward means it represents the 360. After that 270. After that here 360 only they tell. Here you see 2 pi. 2 pi means it is a fourth quadrant. 360 in the, I rotate from downward. Downward represent the 360. So 360 in the fourth quadrant. In the fourth quadrant, we know that cos and secant function only positive, remaining functions are negative. Remaining trigonometric functions are negative because all silver T cups. Cups means it represent the cos and secant. Therefore, cos and secant are positive, remaining functions are negative. So therefore we write it, so cos of 2 minus pi by 4 is cos pi by 4, but the sine of 2 minus pi by 4 is minus sine pi by 4. Okay, so therefore minus sine pi by 4 plus cos pi by 4, because the angle lie in the fourth quadrant. The fourth quadrant means cos and secant only positive. So cos of 2 pi minus theta is a cos theta. So I represent the angle is pi by 4, cos pi by 4. Sine of 2 pi minus theta equal to minus sine theta. So minus sine into angle is pi by 4. So and next Sine 45 degrees 1 by root 2 I substitute, plus cos 45 degrees 1 by root 2. You see the sign are minus 1 by root 2 plus 1 by root 2 cancelled. Our answer is 0. Therefore f of 7 pi by 4 equal to 0. This is y. Y equal to f of 7 pi by 4 equal to 0. So y equal to 0 means the x answer is x equal to, that means x value is 7 pi by 4 comma y answer is 0. So 7 pi by 4 comma 0. This is our second point. This is the inflection point. Okay, INFL, here L will come. So this is the inflections point. So in this problem we found the concavity and the inflections. Everything we found from this problem. Third subdivision, you see, third subdivision, first problem, third subdivision. F of x equal to 1 by 2 e power x minus e power minus x. So given f of x equal to 1 by 2 e power x minus e power minus x. So now you take the differentiation. So f dash of x equal to 1 by 2, you differentiate the e power x. So e power x minus, I write it in the middle. Next differentiation of e power minus x is minus e power minus x. So already there is a minus in the middle. So minus into minus plus e power minus x. Therefore f dash of x equal to 1 by 2 e power x plus e power minus x. Next again I take the differentiation, second derivative. So f double dash of x equal to, second derivative means I differentiate the first derivative. From this I get the second derivative. So again I differentiate the first derivative. So f double dash of x equal to 1 by 2. Now that means f double dash of x 1 by 2 into, I differentiate the e power x. So e power x. Next there is a plus symbol, I write it in the middle. Next differentiation of e power minus x is, that means you see e power of minus, you see the power. So power is minus means you write it the minus of e power minus x. So minus of e power minus x means already there is a plus, plus into minus minus, minus e power minus x. This is the answer for f double dash of x. So f double dash of x equal to 1 by 2 e power x minus e power minus x. Now we find out the f double dash of x equal to 0, because we tell about the intervals of, we make it the intervals for that purpose, and concavity and inflection point, everything we will find out. So for that reasons I take f double dash of equal to 0. So f double dash of equal to 0 means now we know the f double dash function 1 by 2 e power x minus e power minus x. Now this is equal to 0. This is equal to 0 means, that means 1 by 2 e power x minus e power minus x equal to 0. 2 is cross multiply in the 0. So numerator e power x minus e power minus x equal to 0. If we write minus sign in the right hand side, so e power x equal to e power minus x. Therefore e power x equal to, we write it e power minus x is 1 by e power x. So I just doing the cross multiplication, e power x dot e power x equal to 1 and e power 2x equal to 1. No, so therefore e power 2x equal to 1 means I take, that means x equal to, I represented here, because now I taking the log on both sides. So log on both side means log e power 2x equal to log 1. So log and e cancelled. So 2x equal to log 1. We know the log 1 value. Log 1 value equal to 0. Log 1 equal to 0. So 2x equal to 0. 2x equal to 0 means number not equal to 0. So we take x equal to 0. So therefore the point is x equal to 0. So I mark it in the interval. Minus infinity comma plus infinity. So therefore I write it. Therefore the interval is, you leave it this interval. Okay, so you consider only x equal to 0, you don't take this interval. So therefore the number line is minus, basically we know that number line started from minus infinity to plus infinity. Minus infinity represented the negative numbers 0 and infinity represented the plus numbers. So basically number line means started from minus infinity to plus infinity. Now our point is x equal to 0. I represent x equal to 0 means this is a x equal to 0 point. Now I make it the interval. So the intervals are, that means minus infinity comma 0, 0 comma infinity. These are two intervals. So now I make it the interval. First column is interval, second column is sign of f double dash. So concavity means we check it from f double dash. So sign of f double dash and monotonicity. The first interval is minus infinity comma 0. So I take any numbers from this. Suppose I take the 0. Before the number I take x equal to minus 1. So x equal to minus 1, I substitute in the f double dash of x. So I got the sign minus in the answer. So I represented the minus. So therefore minus means that means concave downward. I write it here. Next 0 comma infinity. So I choose any numbers between this. 0 comma infinity means it is a positive numbers it denote, but we cannot take the 0 and infinity. We only take the between values, only take from this limit, because it is a open interval. Open interval means the boundary point not included, it is excluded, only between values only we taken. It is the open interval. So 0 comma infinity means 0 not taken, infinity also not taken, only between the values. Between the values means I tell about 1 2 3 4, it goes on. So suppose I take the small number x equal to 1, I substitute in the f double dash of x equation. So I got the symbol plus in this answer. So plus means I represent concave down, upward. So concave upward. So the curve is concave upward on 0 comma infinity. The curve is concave downward on minus infinity comma 0. Therefore f double dash of x changes its sign when it passes through x equal to 0. You see why I write this means, you see the sign changes, alternate sign we having minus plus. So alternate sign. So sign changes means which point we have the sign changes means x equal to 0 point. So from this table I write it, f double dash of x changes its sign when it passes through x equal to 0. So x equal to 0 means, so I substitute x equal to 0 in our given function. We know our given function f of x equal to 1 by 2 e power x minus e power minus x. So now I substitute x equal to 0. So 1 by 2 e power 0 minus e power minus 0. Minus 0 again we write it the 0, because 0 has no sign. All the numbers has the sign, but 0 not have the sign, only it represented the 0 only. Minus 0 is also represented plus 0, and plus 0 also represented the plus 0. So e power 0 minus e power 0. So we know the value for e power 0. The value of e power 0 is 1. So I substitute here minus 1 minus 1. So 1 minus 1 cancelled. Therefore the answer is f of 0 equal to 0. So f of 0 equal to 0 means f of 0 we take y. So y equal to 0. So we know the x point is 0, y point is 0. So therefore the point is 0 comma 0. This point we taken point of inflection. Therefore the point of inflection is 0 comma 0. This is our inflection point. Second problem, find the local extrema for the following functions using second derivative test. F of subdivision 1, f of x equal to minus 3x power 5 plus 5x cube. Find the local extrema. They ask about the local extreme for the following. So here extrema, not extreme, it is a local extrema for the following functions using second derivative test. So subdivision 1, f of x equal to minus 3x power 5 plus 5x cube. This is subdivision 1. From this we tell about the local extrema. So they ask about the using second derivative. So from the second derivative we find out the local extrema. So first I write the given function. So f of x equal to minus 3x power 5 plus 5x cube. This is a given function. Next now I find out the f dash of x. So both the side differentiate with respect to x. So f dash of x equal to minus 3 into, I differentiate the x power 5. Differentiation of x power 5 is 5 into x power 5 minus 1 is 4. So 5 into x power 4. Already there is a number minus 3 into 5 into x power 4. So minus 3 into 5 or minus 15. So minus 15 x power 4 plus again 5 into x cube. Differentiation of x cube is 3 into x square. So 3 into x square means 5 into 3 is 15 x square. So f dash of x equal to minus 15 x power 4 plus 15 x square. So next f double dash of x. F double dash of x means again I differentiate. Second time I differentiate the f dash of x. So differentiate with respect to x. So f double dash of x equal to minus 15 into, I differentiate the x power 4 into x cube. So minus 15 into 4 or minus 60. Minus 60 into x cube plus next 15 into I differentiate the x square. Differentiation of x square is 2x. So 15 into 2 is 30x. So in the next step, f double dash of x equal to, now you see the common factor from this factor. Here common factor is 30x. So 30x means I take the common factor from this number, from the two terms. So 30x is a common. So I take the common factor from this term. So I write it 30x into, I take the 30x from the first term. So I take the 30. So remaining 60 we factorize into 30 into 30 into 2s are 60. So 130 I taken. Remaining factor is minus 2. Next x is cube. X is cube, I take the x from this x is cube. So remaining factors I take the x from this x is cube means, so remaining x square. So here x square will come. So therefore minus 2 x square plus, so minus, that means so I take the, here I take the 30x. So 30x means minus 2 into x square will come. Minus 2 into x square plus 1 will come here. So minus 2 x square plus 1. Therefore so our f double dash of x is, that means I take the 30x from the factor from this term. So the answer is 30x into minus 2x square plus 1. So this is the answer for f double dash. So now I take f dash of x equal to 0. So f dash of x equal to 0 means, now we know the f dash of x, minus 15x power 4 plus 15x square equal to 0. So I take, from this I take the minus 15. So minus common factor, here common factor is 15x square. So I take the minus 15x square. So minus 15x square means 15 I take from the first term. So remaining minus sign also I take the from the first term. Next minus 15 I write it. Next x power 4, from the x power 4 I write it, I take the x square. So I take the x square from the first term. So minus 15x square I take from the first term. So remaining term is x square. Next so I take the minus sign from the each term. So here minus sign, so I put it the plus, but here no minus sign, so I write it the minus. So no minus sign means it will change the sign. So minus, and 15x square I take. So remaining term is 1. So minus 1. So equal to 0. The next step, minus 15. Now you see here two factor. First factor is minus 15x square. Second factor is x square minus 1. So equal to 0. So you write it minus 15x square equal to 0. X square minus 1 equal to 0. Therefore numbers not equal to 0. Any numbers not equal to 0. So only variables only it comes to 0. So I take x square equal to 0. X square equal to 0 means, that means and next factor x square minus 1. So x square minus 1, x square equal to 1. Therefore x square equal to 0 means x equal to 0. X square equal to 1 means x equal to plus or minus 1. Therefore the critical points are x equal to 0, 1, minus 1. This is the critical points. Therefore so we find the critical points because they ask about the local local extremum. So local extremum means it need the critical points. So we find the 3 points, 0, that means 1, minus 1. Now I substitute the first point, x equal to minus 1. So x equal to minus 1 in the second derivative, because they tell about using second derivative. So test. So that means with the using of the second derivative we calculate the local extrema. So I consider the second derivative, f double dash of x equal to, that means f double dash of x equal to 30x into minus 2x square plus 1. Okay, so now I substitute x equal to minus 1. X equal to minus 1 means 30 into minus 1 into minus 2 into x cube means minus 1 whole cube. So plus next one, now I take the, here I write the x equal to minus 1. So I substitute, that means you see, you consider f double dash of x equal to, you write it 30 into, you just only take 30. 30 is a common factor, so you take a, so you write it as 30 into, so 30 only you take from the each factor, so the remaining term is minus 2x cube plus x, no x will come here. So now I substitute the x equal to minus 1, so x equal to minus 1 means f double dash of minus 1 equal to 30 into, you substitute, that means minus 2 into x cube is x is minus 1 whole cube, x equal to minus 1. So next minus 30 into, that means minus 1 whole cube is minus 1, so minus 2 into minus 1 is plus 2, so plus 2 I write it, next minus 1, so 2 minus 1. So the next step I write, that means 2 minus 1 means here I write it the, that means here I write it the minus 2 and minus 1 whole cube, so minus 1 whole cube means minus 2 minus 1, so 2 minus 1, therefore so here first you consider that means already we find the f of x and f dash of x, f double dash of x, you don't take any common factor, you just keep it as it is, that means f dash of x equal to minus 15x power 4 plus 15x square minus 60x cube plus 30x, you don't take any common factor, you only consider f of x is minus 3x power 5 plus 5x cube, f dash of x equal to minus 15x power 4 plus 15x square, f double dash of x equal to minus 60x cube plus 30x, you just keep it as it is, so you don't take any common factor from this term. So now in the next step, now we find out the critical points. So critical points, we need the critical point means we take the f dash of x equal to first derivative equal to 0, so first derivative equal to 0 means there is a first derivative answer, so this equation equal to 0. So from this we find out the point, that means the point is already I told, that means x equal to 0, x equal to plus or minus 1, that means 0, 1, minus 1. So now I substitute the point, the first point x equal to minus 1, small to big, so minus 1, so I substitute x equal to minus 1 in the f double dash of x, we know the f double dash of x equal to minus 60x cube plus 30x, now I substitute x equal to minus 1, so x equal to minus 1 means minus 60 into minus 1 whole cube plus 30 into minus 1, so minus 1 whole cube means again it comes to minus, already there is a minus, so into minus into minus plus, so 60 again here 30 into minus is minus, so in the middle minus 30, so 60 minus 30 is the 30, so f double dash of minus 1 equal to 30, so 30 is a positive, we represented by greater than 0, so we represented the greater than 0, therefore it is a local minimum. So at the point x equal to minus 1 is the local minimum. Now we find out the value, local minimum value. So why I tell it is a x equal to minus 1 is the local minimum means the value is I represented by greater than 0, positive answer. Positive means I substitute x equal to minus 1 in the f double dash of x, I got the answer plus 30 means I represented greater than 0. Greater than 0 means I tell it is a x equal to minus 1 is a minimum value, local minimum not value, local minimum. Now we find out the local minimum value, so I substitute, so now I tell it is a local minimum, x equal to minus 1 is a local minimum, not maximum, it is a local minimum, because our f double dash of minus 1 comes to the answer is plus 30 not minus 30, plus 30 greater than 0, you just substitute in this equation, you don't not in the second equation. Okay, so next local minimum find out, after we find out the local minimum value f of minus 1 equal to, I substitute minus 3 into, we know the functions, I go and substitute x equal to minus 1, so f of minus 1 equal to minus 3 into minus 1 whole power 5 plus 5 into minus 1 whole power 3, so minus 3 into, this is minus 1 whole power 5 is minus 1 plus 5 into minus 1, so minus plus 3 minus 5 is minus 2, so therefore f of minus 1 equal to minus 2, this is our answer, therefore local minimum value is minus 2. The point is minus 1 comma minus 2, this is the local minimum. So next we calculate the x equal to 1. You see Now I substitute x equal to 1 in the f double dash. So I tell the equation f double dash of x equal to minus 60 x cube plus 30x. So now I substitute x equal to 1. So minus 60 into 1 cube means minus 60 plus 30 into 1 means plus 30. So minus 60 plus 30 means minus 30. So minus 30. So f of 1, I substitute x equal to 1 in the f double dash. I got the answer f double dash of 1 equal to f double dash of 1 equal to, here our answer is, that means our answer is f double dash of 1 is equal to minus 30. So minus 30, not 90. F double dash of 1 equal to minus 30. Here plus 1 will come. F double dash of minus, that means plus 1. F double dash of 1 equal to, that means minus 30. Minus 30 means we represented the less than 0. Less than 0 means it is a local maximum. So x equal to 1 is a local maximum. Now we find out the local maximum value. So I substitute, therefore local maximum value is x equal to 1 at the point. So now I substitute in the function f of 1, we know the function f of x. So I just substitute x equal to 1. So f of 1 equal to minus 3 into 1 power 5 plus 5 into 1 power 3. I just substitute minus 3 plus 5, 2. Therefore at x equal to 0, next therefore the local maximum value is 2. Already we found the local minimum value. Local minimum value is minus 2. So therefore again third point x equal to 0. So I substitute in the f double dash. So I substitute f double dash, that means minus 60 into 0. So 0 plus second term 30 into x, 0, 0. So 0 plus 0, 0. Our answer is 0. So f double dash of x equal to, that means f double dash of 0, it is that means f double dash of 0 equal to 0. So from this I represented f double dash of x less than 0. So the second derivative test does not give any information about the local extrema at the point, because from this we cannot conclude anything. Okay, because a plus and a minus symbol only we conclude. That is a plus sign means I represented the greater than 0. Minus symbol means I represented the less than 0. But equal to 0 we cannot represent. It is a greater than or less than. So we cannot. That means find out the local extrema from this point. Therefore I conclude the answer. Therefore local minimum equal to minus 2. Local maximum equal to plus 2. This is our answer for this question. We complete the class.